Assalamu alaikum. This is Abdullah Khan from Dawood University of Engineering and Technology. I am going to share my topic concentration dependent term of a rate equations. So, rate law and reactions order. The reactions rate law express relates the rates of a reaction to the concentration of the reactants. Each concentration is expressed within order or exponents. The rate constant converts the concentration expression into the correct units of rate ms inverse. For the general reaction, A plus B is going to make C plus D. So the concentration and rate is directly proportional to each other. As I have mentioned, the equation rate is equal to rate constant K concentration of A into the concentration of B. Here is showing this equation rate is directly proportional to concentration. If we change the concentration of any reactant, rate will also be changed. X and Y are the rate orders determined from experiment. X and Y are not stoichiometric coefficients. Let us see what's the relationship between rate law orders and the rate constant K. For the first rate law, rate is equal to K. It is zero order reaction and unit of K is M as inverse. So second one, rate is equal to K concentration of A first order with respect to a first order oral. The unit of this will be second inverse. So the third one, rate is equal to K concentration of A with power 2. Second order with respect to A, it's mean that power 2 shows us second order reactions. It is a stoichiometric coefficient, second order oral. So the unit will be M inverse into S inverse. Same the units will be for the below rate equations as mentioned for the first order with respect to A and the first order with respect to B. In the fourth one, if rate is equal to K concentration of A into concentration of B. For the fourth, if rate is equal to concentration of A, B, C with rate constant multiply, so there will be first order with respect to A, first order with respect to B, first order with respect to C. So the overall rate, the overall order will be third order of reaction and units of this will be M inverse 2 into second inverse. So what is rate's law? Rates raw rate constant and others are determined experimentally. The order of a reactant is not generally related to its stoichiometric coefficient in a balanced chemical equation. As shown the equation over here, F2 plus 2ClO2 is going to make 2FClO2. So here one shows us the order of reaction. It is the first order of reactions. So let me explain example related to the concentration and rate, and from it we will find what's the relationship between rate and concentration. We will find it by calculations. So we have given experiment numbers and concentration of NH4 as well as the concentration of NO2. We will observe the rates equation for each changing of concentration. Let's see for the first experiment number concentration of NH4 is 0.0100, while the concentration of NO2 is 0.200. Its rate is 5.4 exponent minus 7. In the second one, experiment number, so the concentration of NH4 is 0.0200. Here is showing us we have increased the concentration of NH4. Let's check what will be the reaction on the rate while we are keeping constant and while we are keeping NO2 as a same value with the previous. So if we check the rates of reaction, so it is increased with the increasing of concentration of NH4. We also proceed the same method in 3 and 4th. So compare experiment 1 and 2 tell us that when NH3 doubles, the initial rates will also be double because it is directly proportional to each other. Let's explain the another numericals for it, concentration and rates. Likewise, compare experiment 5 and 6. When we double the concentration of NO2, the rate, initial rate will also be double, and we will keep the concentration of NH4 constant. We will not change the concentration of NH4, while in these we will change the concentration of NO2. And here is also the same effect is appearing. If we increase the concentration of NO2, the rate also increase with the increasing of NO2. It's mean that it's proof that concentration is directly proportional to the rate. So what's the expression for rate and concentration? If rate is directly proportional to NH4, rate is directly proportional to NO2. So we can write that rate is directly proportional to concentration of NH4 into concentration of NO2. So if we are going to remove the proportionality sign, we will add K. This is the rate constant. Now equation will become rate is equal to rate constant concentration of NH4 into the concentration of NO2. This equation is called the rate law. So integrated rate law express what's the goal of integrated rate law, express concentration as a function of time. So why it express? So experiment delta is typically in concentration vs time. How? Integrate the expressions of rate law. Before discussing this equation, let me move toward what's the experiment data for the concentration vs time. I have plot the graph for the concentration vs time. We can see over here, if time increase, the concentration also increase and order also increase from 0 to first order reaction and from first to second order reaction. It's mean that with the increase of time, concentration also increase. Now come toward the previous slide. So here are reactions are given. If for the first, if we see for the first reaction, if A is going to make product P at a zero order reaction and differential form as given below, differential of component A divided differential of time is equal to minus K, mean minus rate constant. So integrated form will be concentration of A is equal to constant minus KT. So for the second equation, if A is going to make P, so its order is first and differential form is D concentration of A divided dt is equal to minus K concentration of A. Integrated form ln concentration of A is equal to ln constant minus KT. If we see for the third equation, if A is combined with A is going to make phi at a second order reactions, and the differential form is this will be a half d concentration of A divided dt is equal to k concentration of A with power 2. Here to indicate us the order of reaction, what type of reaction it is. It is zero order, first order, second order, so on. And if we see its integrated form, integrated 1 upon concentration of A is equal to 1 upon constant plus 2 kt. Let's move toward the final equations. If A is combined with B to make product P, it is also second order reaction. dA divided dt is equal to minus k concentration of A into concentration of B. Integrated form is showing that kt is equal to 1 by B naught minus A naught ln B naught concentration of A divided constant into B. So why we have mentioned in the third equation half while in the fourth equation 1? In the third equation we use the same reactant A plus A, while in the fourth reaction we use different reactant, and A and second one is B. So here is numerical. Let me solve it. I have solved it, so let me revise it. A certain reaction has a rate given by minus Ra is equal to 0.005 concentration of A with power 2 mole per centimeter cube in 2 minutes. So if concentration is to be expressed in mole per liter and time in hours, what will be the value and units of the rate constants? This is the rate equation for these reactions. R minus Ra is equal to K concentration of A power 2. So the units of a rate reaction is mole per cm cube into minute, while the units of concentration of A is mole square per liter square into hour. So if we arrange these equations, these units, so we will get liter square into 60 minutes divide a centimeter cube into minute into mole. So if we arrange this, and we also given in the equation 0.005 Ca की power 2, so we will multiply 0.005 into 60 to get the value of rate constant. While we take 60 in this equation just to eliminate the minutes from these units, that's why we take 60 minutes in this to make the unit of rate constants. So let's move to what is elementary and non-elementary reactions. Elementary reaction. In elementary reaction, the stoichiometry of equation reflect in the rate equations. Equation is given below. If A combined with B is going to make product R, so the rate equation for this is minus Ra is equal to K concentration of A into concentration of B. It's mean that stoichiometry of this reflect in the rate of reactions. So this is the elementary reaction. We will further explain elementary and non-elementary after at the end of this lecture. So let's move toward non-elementary reaction. So what's non-elementary reaction? When there is no direct correspondence between stoichiometry and rates, then we have non-elementary reactions. If there is no correspondence of rate of stoichiometry with the rate, as we have shown in the previous elementary reactions. So the classical example of non-elementary reaction is duet, hydrogen and bromine. If hydrogen combined with bromine is going to make 2HBr. Red equation is like this. As you are seeing this, stoichiometry does not reflect in the red equation. So let's move elementary and non-elementary reaction. What is elementary and non-elementary reaction? Let's me discuss difference both of them. The reaction in which the molecule react exactly as the stoichiometric equations written for reactions is called an elementary reaction. As I have told you, elementary reaction is that in which stoichiometric coefficient reflect in the rate reaction as shown in the equation. So for the non-elementary reactions, it does not reflect as stoichiometry in the rate reaction. So the reaction in which formation of product from the original reactants occur through a series of steps are called as non-elementary reaction. So we observe non-elementary reaction as a single reactant rather than elementary reaction in series because the amount of the intermediates formed is negligible, small, and cannot be detected. Elementary reactions are single step reactions, whereas non-elementary reaction are multiple step reaction. Thank you.